Welcome in the section number 3. In this section, we'll be focusing on the 4 concepts that are very important for functional programming and also for composing bigger applications from Scala components. So we'll be looking at the control structure, packages, imports, and recursion. So firstly, we'll be piecing together our logic with control structures. We'll be looking at the conditionals and pattern matching. Then we'll be doing iterations and exceptions with try-catch. Also, we'll improve the imperative try-catch approach with functional programming using try monad. Then we'll be using packages and libraries, we'll be creating them, and we will focus on the package object. Finally, we'll be doing recursion. We'll see that tile recursion is an optimized version of the ordinary one. And this is a first video in which we'll be piecing together our logic with control structures. So we'll be looking at the conditional if, we'll be doing pattern matching, and we'll be leveraging pattern matching with case classes. So let's start from the simple case. So we can see that we should use simple pattern matching. So we are creating an X and assigning 2 to it, and then we are using the match keyword. This is a very important keyword in a Scala and every functional programming. So here we are matching, so if the X is case 0, so it means if it is equal to 0, then you are just returning 0. Otherwise 1, 2, and if it is other than 0, 1, 2, we are just returning other. So let's start the test and see that the result is equal to 2. You can right now have an impression that this is very similar to the switch statement, but pattern matching is a way more powerful. For example, it allows you to decompose your case classes. What does it mean? Let's take a look. So we are creating a hierarchy of classes. We are creating a message that is an abstract class, a message that just extends message and gives a text, and B message that has a price. So we can see that both of those messages has different types of fields. Then we have a match message method that is matching those messages. So we can see that if the message is an A message, then we are taking a text, and that text will be extracted from the message, and here we have an access to the text. We can do to uppercase and it will just return this type. If it will a B message, then the price will be extracted and we are multiplying it by 10. We can see that it will return the any. So if you remember from the first section about hierarchy of inheritance in Scala, any is a subtype of anything. It cannot be anything different because here we are returning string, here we are returning the integer, so one common type is any. So at the return we have a result A and result B. We can see that result A is equal to some text because it was to uppercase it, and result B is equal to 1000 because we multiplied it by 10. So we can see that pattern matching was able to extract values and apply some logic on top of it. Finally, let's take a look at the Scala condition. It is a little bit different from the Java because if is just a function. So we can see that if A is higher than B, then we are returning A, otherwise we are returning B. We don't need to type return because it is implicit. Every if expression is just returning A, one value or different one. So here 1 and 20, max will be of course 20. Let's start the test and see if that is a case. We can see test passed.